Hi everyone. Thanks Denise and thanks Andre for organizing this wonderful event. So Zurich Instruments decided to take part because we really loved it in the last couple of instances. So today what we'd like to present you Zurich Instruments and tell you about mine and Chunyan's journey from academia into Zurich Instruments. And as you slowly coming in, for those of you who don't know much about Zurich Instruments, what we basically do is we produce scientific instrumentation like locking amplifiers, arbitrary waveform generators, and quantum computing control systems that you can see over here, boxcar averagers and impedance analyzers. And all these instruments are based on the FPGA board and perfectly designed low noise front end. And with the Lab 1 user interface on top, our users can actually focus on science without having to build their own instrumentation. So let me first start by telling you a little bit about myself. I come from Serbia, that used to be part of Yugoslavia. Back in the day, I always knew I wanted to study physics. We had a lot of competitions at school, and both girls and boys could equally participate in learning about science. And it was clear for me that afterwards I would be studying physics, which I did in Belgrade, and this school was in particular very heavy theory oriented, so I knew a lot about quantum mechanics and all the symmetries that bring actually physics into life. And I realized that loving actually condensed matter physics, I wanted to continue my work as experimental physicist to discover all these phenomena. So my PhD I did at Florida State University in Tallahassee, and I did it in a group of Stefan von Molnar, who actually had a long career at IBM Yorktown Heights before that. So the main body of our work was on semiconductor spintronics. So what we wanted to do, we wanted to create useful electronic devices that use spin as the main carrier of information. And we chose particular configuration, a lateral one, where you could have injectors and detectors of the spin. And we wanted to have materials with long spin diffusion length and allow a space for spin manipulation. And during this work, we realized actually that main obstacle for efficient spin injection and detection is at the interface of this hybrid system. So we ended up studying this in a great length, and in particular, we could see in the field emission between these two materials Brillouin function of europium sulfide, which is 100% spin polarized source of electrons. And what's also interesting about my life there is that I also had my son there, and he of course follows me to this day through my journey. And after the PhD, I decided to do a postdoc, but we wanted to go back to Europe to be closer to the family, and I chose University of Basel, where Christian Schoenberger's group work on carbon nanotube quantum dots, and in particular, you could see this as a perfect quantum mechanical system that you can contact with various materials like superconductors, ferromagnets, and look at different properties of these quasi-particles and control them via the gate voltage. So together with my PhD and postdoc work, at the end, if you look, I worked on systems which are perfect qubit candidates, spin qubits in gallium arsenide, carbon nanotube quantum dots for spin qubits as well. And I also worked on graphene, which has long spin coherence life and time for the carriers. And there, at the end of the postdoc, I was thinking, where should I go? Should I continue with academia, or maybe should I go into industry? But it was really tricky because I wanted to find an industry where I could continue being close to science and also have a much broader impact on the community and on the students. And I must say, I was really lucky to find Zurich Instruments back then in 2011. I realized that the companies in Technopark, which is an incubator for startup here in Switzerland, and very interesting part of it was that when I found the ad, I really ticked all my boxes, and I immediately give us a call. And I ended up talking to our CEO Sadiq, who invited me for an interview on the spot. So this was really awesome. So and today there's 100 plus of us. We have different. In addition to Zurich office, we have offices in US, France, Shanghai, and what's very important to understand is that we are privately held, and we have no external financing, which means that from the day one that you come, especially if you work in marketing and sales, you realize that we actually have to sell our products in order for the whole company to be able to develop new product and produce the devices that we make in-house. And so what I thought I should do, actually give you a quick tour of the company. And I first start with our kitchen where we like to meet and talk to one another about various topics. And then from there, you could see people in marketing and sales. And also, if you're a customer, you will first meet my colleagues from technical sales. You can see Magda and Marco here. They're the first contact people, and they try to help customers on the spot or connect them to application scientists. And in this case, we have a number of QT application scientists like Tobias, Chunyan, and Andrea here, and Johannes is actually a student at Andreas Wallraff's group at ETH, and he's also doing partially PhD in our company. So it's really great to have this synergy, and it makes it a really fun part of the work. Then what I also like about the company is that everyone is sitting together here. You can see our CEO Sadiq happy to be taken picture of. Of course, this is pre-COVID time. I had taken for another talk. You can see our marketing and scientists mixing together, working alongside on events, on creating ads and content. And this is extremely exciting part of the work. As you can see now, Damien that you see here is also helping us with this event. And further, if you go through the company, you will go into R&D. You will see office where hardware, firmware, and software are written for our products. This is where we do our design, debugging, and release of software. And once the products are ready, they go into production where we assembly, test, and calibrate them. And finally, of course, we are extremely dedicated to do timely shipping for our customers, and with this, Jana helps us, and you can see here Sandra. She's actually working in R&D, trying to hide from me as I'm taking picture there. So, what is it that I do at Zurich Instruments exactly? So, as application scientist for quite some time now, 9 years. I have quite a few responsibilities. One of them is to manage nanotechnology and magnetism in the company as an application. So other of my colleagues, they have different expertise. The first countries that realize the importance of quantum technologies on the national level, and it's really exciting to work with many of the groups there. And at the end, I manage lock-in amplifier, MFLI, which is something I would be using if I was in the lab today. So I also wanted to show you a couple of things that I particularly enjoyed And this is the quantum technology user meeting that we held in London in 2018, done together with the team and our host, Mark Boitela. There we had, for example, Natalia Ares talking about machine learning in reading out the states of quantum dots. And here you can see Johannes, who is now in IQM. So we really tried to gather a group of people around different qubit technologies, whether they're our customers or not, but we created a lot of synergies there. Second thing I wanted to show you is the work that I happily do together with Center for Doctoral Training, training new engineers for quantum technologies, and this is one of those events, very focused school that they had in the UK. And finally, one of the really rewarding things we did with marketing is creating videos that not only our customers appreciate and learning about the basic principles of operating of the instrumentation, as it's critical to do good measurements. So this video had enormous following due to the high quality of the work that we did there. And again, these lock-in amplifiers that I mentioned are extremely important for many of our customers, but also for those doing quantum technologies, because if you look at the qubit as an abstract two-level quantum mechanical system, it has many implementations. Today we have superconducting and trapped ions as the most prominent ones, as they could break through the scaling barriers. And working with these types of qubits requires different type of technology that Chunyan will tell you more about. But again, we are aware of many qubit systems that researchers are still working on, and we will probably one day also break the scaling barrier and be ready for quantum computing chips. And this is how we actually started this whole journey with our 600 megahertz lock-in amplifier. We realized, working together with Andreas Wallraff, that we could use it to read out the state of the qubits using it, and also building arbitrary waveform generator option on that device. We could do the whole experiment by up and down converting the microwave signal that was needed to read out and excite the qubit state. We could do the spectroscopy. We could do Rabi oscillations just with this system, and just with this system. And also we had a user interface which helped the researcher program understand the raw signal and also collect the data, and finally be able to plot Rabi oscillations and infer the T1, T2 start times and other important qubit characteristics. Another example of use of this system is in the fast readout of quantum dot systems, which are important for spin qubits at the moment. So with the UHF-LI lock-in amplifier, and this RF effectometry method, the researchers could read out the state of qubits within 1 second instead of doing it for a couple of hours. Having all this in place for single qubits and certain types of qubit systems, we're also being increasingly aware of especially superconducting qubits that we could help the most, and that's how we decided to build a quantum computing control system as a part of the full stack. And with this instrumentation, we could reduce the increasing complexity that these systems were facing. And now I will hand it over to Chunyan to tell you more about this system.
I'm Junyan. Thanks, Jelena, for the introduction. It's my pleasure to be here to really introduce our journey from academia to Zurich Instruments. So I'm a QT application scientist. My work is highly focused on quantum technologies, especially quantum computing. I will start with what I'm doing now in the company that is related with quantum mission, and also I will talk a little bit about our roadmap and the product development. So my job is really to help our customers to better understand our instrument, and also to find out the best solution for them. And this is the way we can remove the gap between our customers and our developers. And so furthermore, I also have the chance to manage product development that really for the quantum computing control system. So what is the quantum computing control system? Let me start with our company quantum mission. Zurich Instruments started quantum mission since 2014. That is based on the fact we see a big overlap between the company leading technology. That's really because the big overlap between the company leading technology and the requirement from quantum technology, especially quantum computing. So our goal is really to help scientists and engineers to build practical quantum computers, and also becomes the leading provider of quantum computing control system. So we're more focused on spin qubit and superconducting qubits. And with this mission, we actively participate some international research projects, for example, SuperQ-Line, Open SuperQ, and IARPA Logic Q. And those long-term close collaboration really help our QCCS quantum computing control system develop rapidly and steadily. So what is our roadmap? This you can show in this graph. You see this is a qubit number versus the time here. And we see there are two thrusts in the quantum computing. Technology side is towards better physical system and more advanced quantum technologies. And scaling is more really focused on the scalable practical quantum computers. So with Zurich Instrument, we really trying to help scientists to push the technology development, and will remain our control system highly scalable. So as I mentioned before, that the European Open SuperQ project, we commit to realize 100 qubit system, and we see our technology can really be used to go beyond that. So I guess you're probably wondering, do we have anything there? As I showed probably in the picture already, you already see that we do have some instrument on this roadmap. Since 2014, we started this quantum mission. Customer can already use some instrument, but only few. As Jelena already introduced, like the UHF Ally, and our first generation QCCS that is started from 2018. So we see here all the instrument is first generation products. And in this system, there are a lot of QC specific instruments, and that is used for qubit control, qubit readout, and the system synchronization, and also feedback distribution. So in principle, user can use this entire system to do a certain quantum error correction algorithm. And I joined the company since October 2019, and luckily I got the chance to develop a new product. This is called ATIQ modulator here, and we're so glad to see that this is soon be in the market, and also customer can already benefit from these instruments. And as this application scientist, we definitely spend a lot of time with customers, and it's also very exciting to see the achievements, and also to work together to solve some problems. And here I really like to share some of the achievements from our customers. First, this picture you already seen from Jelena's slide. We have close collaboration with ETH and also TU Delft, University, and also Chinese University. And they use our system as can see something here to really achieve some major milestones. For example, the 7-qubit surface code that is from ETH. And this is red from Berkeley Lab, so they have more full QCCS system. And so that they are working on superconducting qubits. And Quantum Inspire, so we have a long collaboration with Professor Leo Di Carlo, and with the Quantum Inspire project, work both spin qubit and superconducting qubits. As you can see here, this is our instrument. We're so glad to see Quantum Inspire's launched last year. And Junyan is Finnish company, so they really integrate our system and aiming for build a commercial quantum computer. And Intel also used our instrument for their spin qubit, and recently they published paper on arXiv and show their big progress on spin qubit. So there are more and more publications, and this achievements really encourage us to moving faster and to build and develop a revolutionary and more advanced products. So that's why really moving forward. Also according to our roadmap, we are working hard towards to push the second generation products to the market. So here you see this is the SHFQA super high frequency quantum analyzer, which is a qubit readout instrument launched in November last year. So this is first member of second generation products, and it, as I said, it's a qubit readout instrument. It can read out 64 qubits in parallel, and also without any additional microwave generators and hacking mixers. So we're so excited to also inform you here that we're going to have let you know a little bit about myself. So I'm Chinese and grew up in northeast of China here, quite close to Russia. And I study physics, of course, at Shanxi University, and then did my master at University of Science and Technology of China, and then got my PhD at Shanghai Institute of Optics and Fine Mechanics. So here I put the picture. You can see this is rubidium atomic quantum clock, which is the clock I was working for years. And I really like my research because it's not only because it's interesting and challenging, but it's also because I really see a lot of people can benefit from it. Just example that how accurate you can locate yourself today is really because it really depends on how accurate of the atomic clocks on the satellite. So there's no doubt I like to continue my research. So I moved to France and worked at LINIA-SIFT Paris Observatory. So here the picture shows the Strontium optical lattice clock. so which I worked for absolute frequency measurement and international frequency comparison when I was there. And also, I had a plan when I was in France that I like to continue in academia rather than a job in China after some experience. But I think it's better to gain a little bit more experience. So that's why after finish in France, I moved to Germany. So I also changed a little bit my research from trapped neutral atoms to single ions or few ions. There are a lot of exciting physics there, and for example, we see the spectrum of the molecular ion, and also very exciting fundamental physics there. And at that time, I was quite confident that I should get quite okay academia position in China. And but life is full of surprise, and something changed in my personal life that also changed my trajectory. Not back to China, but I went to another research position. So I moved to Sweden, worked at Lund University. So here, the crystal I was working on most of the time, and as a senior role, my research in the group also covered quite a lot of different things, from quantum metrology, quantum information, also to medical application. And it was really exciting and really nice time there. And also the time I sort of had the feeling that I would like to settle down. I don't like just a few years moving around. And after a very careful consideration, I decided to go to industry. And mostly it's because I would like to a little bit close to the society and have a little bit wider spectrum about what I can see. And so I actively searched a job, and then I found a job post from Zurich Instruments, and I really felt that job has very strong connection with academia, which means fit my research background very well. And also I see the people, during the interview, I really see the people have very strong passion that they really going to help to build quantum computers. So that's why I moved to Zurich Instruments. And so that's all about my journey. So it's not really optimized for something, but time to time, I'm really trying to understand myself better and to see what is the best thing I would like to do. That's all about myself, and in the end, I would like to highlight two other events from the company. One is a career talk that is from 5 p.m. Another is a career booth. So welcome to join our career fair talk and also visit our career booth. Thank you.
I see that you want to grab a mic.
So I've grabbed it. Are there any questions in the chat for the Zurich team? Are both of you located in Switzerland?
Yes.
You're lucky. Wonderful place to live. I want to remind everybody to go to the booth later on today. It's important that you go, and I think it's really great to see people's journey. One of my questions to you is, do you feel that employees for Zurich Instruments need a master's or a PhD to work there? What can you tell us a little bit more about what you're looking for?
Sure. If you, I'll take that one. Maybe Chunyan can add a few things. But what's important definitely when you work with scientists is to have a PhD, because you can actually understand the path that let's say researchers are going through, and that's an important asset. Master studies, we also have students coming in doing internship, but I also showed a couple of levels of work one can do in technical sales, where for example, you don't necessarily need a PhD degree, and you are still closely connected with researchers in this process.
I know about technical sales, so that's a good avenue for people. Can you, what's your biggest challenge? One of the questions is, what's your biggest challenge? And then I think someone wants to know about control systems, but I think we could take that offline. Maybe talk about your challenges, or what you see some of your challenges are today.
Chunyan, you want to take it? Is it personal challenge or challenge as a company, or both?
I would say both, or, yeah.
Okay, I can start. Just my personal feeling. So to me, it's really first in the beginning, the challenges really make the transition smooth, because I'm definitely from academia. I have academia thoughts, and for different things, the way I'm working on, and that's slightly different compared with just in the industry, and take a little bit of time to really get used to. But the nice thing is really a lot of people support you. Like Jelena, when I came to the company, she's the coach for me, and really that really helped me to really speed up very, very fast, and to really to know the company every part, and that's really helped to make this transition very smooth. So I guess in other challenges is also when the working is like going on, there are more and more in the challenges probably from the work. But I would say that challenge also make the or more professional, and can help customer better. So
yeah. Yeah, I just wanted to echo what Chunyan just said about the transition. What you will find is stepping into industry is it's going to be a little bit bumpy. However, what I found is development opportunities that you have are quite different than those in academia, and I'm sure you will appreciate it, and actually it will help you grow as a person, not just as a professional.
So a couple other questions. You mentioned interns. Do you take undergraduate interns, or could you talk a little bit about your intern program? Is it master's level, or?
Yeah, so we depending on what we need done, we do take interns. They're usually on a master's level. However, again, depending on what we need, we could probably also take undergrads, but that's probably going to be tied with Switzerland, most likely, especially in this in this climate. But mostly we do masters interns.
Another question from Razier was, is your company also looking for engineers in addition to physicists, or mostly physicists? And then is it theoretical physics or experimentalists? Could you talk a little bit more?
Sure, I'll say a few words. We actually have one, if not two, theoreticians. That's recent addition. Engineers by all means. We have engineers and physicists in. So these are definitely both profiles that we're looking for. And yeah, experimentalists, it's much more natural because we build instrumentation for experimentalists. I can only tell you that theoreticians are keen on understanding how we do stuff as well, because it's also kind of a feedback for them, especially those working on qubit systems.
One more question on the internships. Looks like we're having a lot of interest overall. But internships, is there a duration? Is it a typical length, or is it fluid?
It's usually 6 months.
Okay.
Usually 6 months. Mm-hmm.
And this is a stupid question from an American, but are you guys working virtually or are you in the office?
We're definitely not in the office.
Okay.
We are, well, those, actually, it's a regulation. Those that have to be in the office, they're there, and there are strict COVID regulations. We in marketing and sales don't really need to be in the office. Both Chunyan and myself, we have instruments at home, so and our little new desks and so on. And on and off, we could go into the office, but there's no need for now.
Okay, well, same with us. Sales types don't need to go in the office. One of the questions is, could the internships be converted into a full-time job?
Absolutely. I'll take this from Chunyan because we have a great example. Mareike, she's an engineer. She came as an intern, and we were doing sports together. And she said, "Well, I would like to stay." And I asked her, "Well, did you ask?" And she said, "No." Well, I go ask, and she asked for a job during the internship, and she's now our full-time employee. So by all means.
Yeah, I actually have found jobs by doing things like internships, and it's just a great way to get in the door and meet people and prove how good you are.
Absolutely,
So
yeah.
especially, if I might not have all the tick marks on what they're looking for, it's always good to bet on yourself and try.
Exactly.
And so Faiza is asking about theoretical physicists, and I think you just mentioned you had two?
We definitely have one, if not two, someone that maybe worked half-half. It's pretty unlikely, I have to tell you. However, it could be something that you shouldn't give up and look for opportunities like this, not just with Zurich Instruments, but in other companies. It's not easy, I can tell you that.
Yeah, I would also like to add a few. So, in fact, we, like Jelena said, we recently just have one application scientist who is indeed a theoretician. In the software part, we definitely need because we are doing quantum computing, not just software that you can make something, your computer faster or something like that, but really to program gate, some algorithms and so on. This really need people really fully understand the algorithms and to know how to optimize and so on. Those people have those knowledge to be in a company. And yeah, in general, they're also very welcome. And yeah, so
Absolutely.
this is one example.
So I think there's a lot of open-ended questions. Where do you see Zurich Instruments helping advance quantum computing? And I see you're certainly working with some leading manufacturers. So that's awesome. What is your goal? Is it to integrate with more quantum computing companies, or maybe talk a little bit about where you see your company going over the next 3 to 5 years? Tough question.
It's not too tough. Chunyan, would you like to say a few words? I mean, Chunyan already talked about it in her presentation. We definitely see us as a producer of the full instrumentation stack. So on top of the control and readout electronics, one needs the brain of the whole system to be able to handle the complexity and optimize the operation. So this is quite complex, and we what we aim is to help quantum computer makers with our instrumentation that they can integrate into the quantum computers, like IQM,
Great.
for example.
Yeah, great. Who's doing a lot of great stuff. Any closing comments? We have 3 minutes, and I know there's been a lot of just variety of questions, so I don't know if you want to say something to summarize and encourage people to come to your career room later on.
Yes, please come. It was great to be here. Thanks a lot for organizing. Come, write to us. Feel free to contact us directly as well. And we definitely strive on people like you, and women are by all means welcome. We need more women. That's for sure. And we really love to hear from all of you with more questions.
And there are also men in the audience, so
Absolutely.
everybody
Nice
is welcome. So just thought I'd add that we welcome all of you. There are a lot of positions open, and I think it's an exciting, as everybody knows, this is a really exciting field to be in, and Zurich Instruments is certainly a leader. Anything else you want to say before we move on? Concluding?
I think that's it. Come see us at the career booth and keep in touch.